Good morning, grade 7 students. In this session, we're going to talk about the respiratory gaseous exchange. So this respiratory gas exchange, we're going to continue what we have started before about the gas exchange in the aquatic medium in this experiment where we have the experimental procedure. So we have to place a goldfish in a water enclosure, and then we put the oxygen probe. So we place it in the water enclosure, and then we put the oxygen probe. After this, what do? We follow the evolution, meaning the change of the oxygen content in the water for 5 minutes using this apparatus, the digital oximeter. Also, we have a control measurement. What the meaning of a control? Control one, it's without the fish, meaning that there is no fish. So no fish experiment, the same experimental setup, all of them they are the same except for the fish. So we don't have the fish, and then we move to draw out the results in the graph of document B. Before I move, these two notes, they are very important notes. First note that the control tube is used to compare and to explain the different experimental results. This one you have to know this. Please, anyone who unmute himself, please mute yourself. So the control tube is used to compare and to explain the different experimental results. And the role of the oximeter is used. Sana Bawal, please mute yourself. So this role of the oximeter is to measure the amount of the oxygen gas. So here, this is the role of the oximeter and the role of the control experiment. Okay, let's move now to talk about this graph. This graph is showing the variation of the quantity of oxygen gas in milligram per liter as a function of time in minutes. So we have in this experiment, what do we have? First, we have this control experiment. This one is trial with no fish, without the fish. So without fish. And the second one was the experiment with the goldfish, meaning that it contains the fish. So here we have one without the fish and one with the fish. Here are the values of the quantity of oxygen gas. Here it's 9.200, so you can say it's 9.2. And here's 8.800, you can say it's 8.8. At the beginning of the experiment, at time 0, the quantity of oxygen was 9.2 in both the control and the one with the goldfish. As the time increases from 0 to about 5 minutes at the end of the experiment, what happened? The quantity of oxygen in the control, it stays the same. It remains the same. It stays constant. Whereas the quantity of oxygen with the experiment with the goldfish, it decreases to a lower level, meaning that the amount of oxygen was consumed. So oxygen gas was consumed by what? By the fish. So oxygen gas was consumed by the fish, and that's why the amount of the oxygen decreases. So here, from now on, whenever the level of any gas decreases, this means that this gas is consumed. While in the control experiment, we don't have fish, so there is no consumption of the oxygen. There is no consume of the oxygen gas since we don't have fish. This is the control experiment, and it's used to compare and explain the different experimental results. Moving now to formulate the tested hypothesis in the experiment. Always and always and always and always, whenever you set the formulate the tested hypothesis, it should be written like this. You have to write the word hypothesis, colon, not then. Maybe the fish absorb oxygen. Maybe the fish consumes the oxygen gas. We are predicting, but should be a logical one. You don't have to say, maybe the fish eat donuts, let's say. This is not logical. So this prediction should be a logical one. This is the hypothesis. Maybe the fish consume oxygen. Why? Because I saw that in the graph, the amount of oxygen in it decreases in the presence of fish. This is the hypothesis. So it should be a logical prediction. Pick out the concentrations of oxygen indicated by the oximeter at the beginning and the end. At the beginning, in both the control experiment and the one with the goldfish, at the beginning, both of them, they were 9.2 milligram per liter. At the end, after 5 minutes, The amount of oxygen here, it decreases to 8.8 milligram per liter. In what? In the experiment with the goldfish. While it remains the same, it remains constant at 9.2 milligram per liter in the one with the control experiment. So what can we deduce here? That the amount of oxygen in the presence of the goldfish is consumed by the fish. That's why it decreases. Now we're going to move to the test that is used to identify the presence of carbon dioxide. Yes, Hassan, do you have a question before we continue?
Yes,
Yes,
Ustaz.
your question is in English, please.
Uh, how did you know the concentration of oxygen is 9.2?
Here in the graph, Hassan, in the graph, look,
Ustaz,
here in the graph, here's 9.2. 9.200. I told you that is 9.2. And here it's 8.8. That's why I know that these lines, they represent for the
okay,
control and the goldfish. So it's here, so it's 9.2. At the end, in the control, it stays 9.2
okay,
here. While in the goldfish, Shusarfia, it decreases to 8.8. That's why. Okay, got it?
okay, thank
Okay,
you.
great. Great, very good. Yeah, let's continue now to the line motor test. What is the line motor test that we talked about this last week? Line motor test is the test that is done to identify the presence of carbon dioxide, CO2. This line motor, in the absence of carbon dioxide, it remains clear, like the one shown in this test tube. While when it reacts with CO2 with carbon dioxide, this lime water it becomes turbid. So the lime water it becomes turbid, or we say it becomes milky, or it becomes cloudy. So this is the presence of carbon dioxide turns the lime water from clear to turbid. This is the way that can we detect the presence of the carbon dioxide. So carbon dioxide
Hi, Ustaz.
can be detected by the lime water test. So if we have carbon dioxide, lime water will become turbid, it becomes milky, it becomes cloudy. So this is the lime water test that is done to identify the presence of carbon dioxide. Here in this experiment, what did we do? We took the water from both the experiment with the goldfish and the one without the goldfish. In beaker A, by raising your hands, in beaker A, the lime water is what? Is it clear or turbid? Hassan Sroor. Yes, Hassan.
In weaker A, the lime water is clear.
Clear. What does this mean, Hassan? It's clear lime water. So do we have carbon dioxide or not?
No, we don't have
So
carbon
there is
dioxide.
no CO2, no carbon dioxide. Very good, Hassan. Thank you. Moving now to beaker B. In beaker B, yes, Jude. In beaker B, the lime water is clear or turbid?
It's turbid.
Turbid. So what does this indicate? What does this mean?
We have CO2.
Very good. This indicates the presence of CO2. So by this way, we can detect the presence of CO2 using the lime water. So here we can deduce that the fish, it releases CO2. And this turns the lime water to be turbid. Since whenever we have the fish, the lime water becomes turbid. So we have CO2. While without fish, the lime water it stays clear. So there is no CO2. So here we can deduce that the fish releases CO2. So here they compare the appearance of the lime water, the shape of the lime water. It's clear or it's turbid. So appearance of lime water is clear, or you can say it's colorless, without a color in beaker A, where the water comes from the enclosure without the fish. While the lime water is cloudy, or it's turbid, or it's milky. All of them, they have the same meaning. Cloudy, turbid, milky, all of them, they have the same meaning. So from the enclosure with the fish. So what can we conclude here? We can conclude that the fish releases CO2, which makes the lime water to become turbid or milky or cloudy. So as a conclusion, the fish consumes, absorbs the oxygen, and it releases CO2. Yes, Leah, your question is before we continue. Leah, I can't hear you. I think you have a problem in your microphone. Fix it, and whenever you have a question, you can ask it later on. Okay? So here, let's move now to talk about diffusion. I want you to remember or memorize this one. This is a reminder for diffusion. What is diffusion? Diffusion is the movement of a substance from a medium of high concentration, high amount, high value to a medium containing low amount or low value. This is the word diffusion. In the lungs, the oxygen diffuses from the lungs that are rich in oxygen gas to the blood that is poor in oxygen. So oxygen diffuses from a medium containing high amount of oxygen, which is the lungs, to a medium containing low amount of oxygen, which is the blood. So these two, you should study them. These notes, this you have to study them. And gas exchange at the level of the lungs. So oxygen gas, it diffuses from where to where? From the lungs that are rich in oxygen to the blood that is poor in oxygen. While carbon dioxide is the opposite. Carbon dioxide diffuses from where to where? From the blood that is rich in carbon dioxide to the lungs that are poor in carbon dioxide. So always and always, oxygen gas diffuses from the lungs that contain high amount of oxygen, that are rich in oxygen, to the blood that is poor in oxygen. Whereas carbon dioxide diffuses from blood, which is rich in carbon dioxide, to the lungs, which is poor in carbon dioxide. So this is related to the diffusion and related to the gas exchange at the level of the lungs. Let's now move to this worksheet. In this worksheet, question number one, the main respiratory organ in the mammals is the lung. Inside the lungs, the exchange is done between the atmospheric air and the blood. The table below shows the composition of the blood entering and leaving the lungs in the man. And the unit here, it's the milliliter. So we have here the quantity of oxygen and that of carbon dioxide in the blood entering and the blood leaving the lungs. Part 1 or Part A. They said in the above table, compare the composition of the blood which enters the lungs to that which leaves the lungs. Hint, I gave you a hint here, and this one is not given in the quiz for sure. You have to use the word more than or less than, greater or smaller. Here, more than or less than, this we have number. Larger and smaller whenever you have, for example, size. So here we have
So
numbers.
you're gonna
We
upload the
have
worksheet solution?
Jude, whenever you have to speak, please raise your hand, okay?
Yes.
So please, whenever you have to use the hint more than or less than, and the solution is already uploaded in the school app since the beginning of the week. So here, we're going to talk about this, and already the solution, we're going to solve it together. So here, the quantity of oxygen in the blood entering and in the blood leaving the lungs. Okay, so let's start. Who can compare the quantity of oxygen in the blood entering and the blood leaving? I need new hands. Yes, Sari. Compare the quantity of oxygen in the blood entering and the blood leaving the lungs. Sari
Okay.
from Saudi Arabia. Yes, start.
Okay. The quantity of oxygen in blood entering the lungs
Yes,
is 15,
15 milli.
which is less than the blood
15.
leaving.
15. What is
And
the unit? Liter.
milliliter.
Excellent. Which is less than
And which is less than the blood leaving, which is 20 milliliter.
20 milliliter. Very good. Which is less than the blood leaving. Pay attention to the mistake that you did. Sari said, thank you, Sari. Thank you very much. So the quantity of oxygen said, and the blood entering the lungs, it was 15 milliliter, which is less than, Sari said, the blood entering. No, it's less than the blood entering. It's less than the quantity of oxygen in the blood leaving the lungs. Okay? So it's less than the quantity of oxygen in the blood leaving the lungs, which is 20 milliliter. So Sari, can you repeat it in a correct way? Yes, Sari? Can you repeat this?
Okay.
Yes. And all of you, please
Okay.
listen to Sari, please, and pay attention.
The
Yes.
the quantity of the quantity of oxygen
Yes. And the blood
in the blood entering the lungs
is,
is 15 milliliter,
yes, which is,
which is
less than or greater than 15 and 20. 15 is less than 20 or greater than 20.
less than 20,
Less than what?
20
The quantity of oxygen in
quantity
the
of
blood,
oxygen leaving the lungs.
leaving the lungs, which is 20 milliliter.
20
Thank you, Sari.
milliliter.
Very good. So let's repeat this. So we have to say the quantity of oxygen in the blood entering the lungs is 15 milliliter, which is less than the quantity of oxygen in the blood leaving the lungs, which is 20 milliliter. Let's now move to the quantity of carbon dioxide. Who's going to answer this? Let's move to Adam. Adam, hi, can you compare the quantity of carbon dioxide in the blood
Yes,
entering and the blood leaving?
yes.
Yes.
The
Yeah,
quantity of carbon dioxide entering the lungs
yes.
is 53 milliliter,
Which is
which is the quantity of
which is,
carbon
you have to
dioxide.
say first. You have to say greater
Which
than or
is
less.
more than the quantity
Excellent.
of carbon dioxide leaving the lungs,
And the
which
blood
is
leaving the
49.
lungs, which is 49. Very good, very good. Excellent, Adam. Excellent. So the quantity of carbon dioxide in the blood entering the lungs, it was what? 53 milliliter, which is less than or greater than, it's greater than, since 53 is greater than 49. So which is greater than the quantity of carbon dioxide in the blood leaving the lungs, which is 49. Part B. Thank you, Adam. Thank you, Sari. Part B. They said,
Welcome.
how can you explain the change in the amount of oxygen and carbon dioxide? Yes, yeah, Aya, what do you think? How can we explain this? This is related to diffusion. Huh?
The amount of oxygen gas decreased and the amount of carbon dioxide increased since the lungs take oxygen from the blood and release carbon dioxide.
Okay, so here you explained correctly, but you have to talk about diffusion. You have to talk about this topic. We have to use this one. These notes that already I told you, you have to study them. You have to say that
Can I
oxygen
say it?
gas, yes, diffuses from the lungs that are rich in oxygen to the blood, which is poor in oxygen, while carbon dioxide diffuses from the blood that is rich in carbon dioxide to the lungs, which is poor in carbon dioxide. This is the solution for this. So first, let's start step by step. First, the comparison, and all of you please pay attention to the comparison. I have a hint here that help you to save time. Okay? The quantity of oxygen in the blood entering the lungs is 15 milliliter, which is less than that. What does that refers to? They're in English now. What does that refer to? Who can tell me by raising your hand? What does that refer to?
It refers to the 15
Raising your hands,
milliliters.
please. Raising your hands before you speak. Take your permission before you speak. Yes, Leia.
It refers to the 15 milliliters.
No, that. It refers to what? To the quantity of oxygen. So instead of saying the quantity of oxygen in the blood entering the lungs is 15, which is less than the quantity of oxygen in the blood leaving the lungs, which is 20, I use the word that. So that you can use it instead of the word the quantity of oxygen, instead of this statement. So instead of saying the quantity of oxygen twice, you can use that. So that refers to the quantity of oxygen. So I can say the quantity of oxygen in the blood entering the lungs is 15 milliliter, which is less than that. That refers to the quantity of oxygen, less than that in the blood leaving the lungs, which is a 20. Also, the quantity of carbon dioxide in the blood entering the lungs is 53 milliliter, which is greater than that. That refers to what? To the quantity of carbon dioxide. dioxide, and the blood leaving the lungs, which is 49 milliliter. Part B, how can you explain the variation? Oxygen gas, it diffuses, and this is, you have to study them from the last week. Oxygen gas diffuses from the lungs, which is a medium rich in oxygen, to the blood, which is poor in poor in oxygen. Sorry. So I repeat, oxygen gas diffuses from the lungs, which is a medium rich in oxygen, to the medium that is poor in oxygen, which is the blood. So this note you have to study. Carbon dioxide diffuses in the opposite direction. It diffuses from the blood, which is a medium rich in carbon dioxide, to the lungs, which is a medium poor in carbon dioxide. And this is everything related to these parts A and B. This note in part B, you have to study it, you have to know it about diffusion at the level of the lungs. Jude and Aya, do you have any question? Raising your hands. Okay.
No, it says I'm just raising my hand, waiting
To
if
answer? Yeah,
question.
yeah. Okay, no problem, no problem. Yeah, lower your hand and prepare yourself for the next question. Next question, figure question number 2. These are talking about the frog respiration. The frog has a pulmonary respiration. Remember when we talk about the pulmonary respiration, those that live on land like mammals and the frogs living on land, they breathe through the lungs. So they have pulmonary respiration. Also accomplished by important cutaneous respiration throughout the skin. Here we have a special characteristic. Skin is composed of a thin membrane of containing large network of blood vessels. This characteristic allow the exchange of the gases between the blood vessels and the surrounding. It passes winter completely immersed, immobile in the mirror. They are immobile. And then in summer, the frog lives near the mirror, get in water for smallest warning. Whenever they hear a warning or some predator coming beside them, they move into the water, but not for a long time. They will get back rapidly. During inspiration, the nostrils open, allowing air to enter into the mouth. Then the nostrils, they close, and the air in the mouth is forced into the lungs. During expiration, what are the nostrils? Here are the nostrils. Here they are opening here. They are called the nostrils. Allow the air to enter the mouth, then to the lungs. Okay? These are the nostrils. So the nostrils mainly they are here inside our body. So during expiration, which is the exhalation. So inhalation and exhalation, they are the two phases of the respiratory movement. Whenever we inhale and we exhale, these are the phases of the respiratory movement. This is the part 4, by the way. So during expiration, the air exits from the lungs into the mouth, and finally, the nostrils are open to get rid of the air. In summer, the needs of frog in oxygen, they are 3 times more than that in winter, meaning that the frog needs oxygen 3 times more than that in winter. Who can give me a prediction? Why? This prediction is going to be the hypothesis. So who can give me a prediction? Why the frog needs 3 times more oxygen in summer than that in winter? Yes, Lamar, what do you think?
Maybe because it's hot, you need more oxygen.
Maybe it's hot, so it needs more oxygen. This is illogical. So this is the hypothesis. This is Lamar's hypothesis. Anyone can give me another hypothesis? Let's see, Adnan. Adnan Arauni, what do you think about this? Can you give me your hypothesis, your prediction? Why the frog needs 3 times more oxygen in summer than that in winter?
I maybe because of the heart.
Okay, Adnan, first of all, pay attention. In the hypothesis, you don't use the word because. You say yes, maybe. Okay?
Okay,
Okay, yes, yours.
maybe of the hot weather.
Maybe of the hot weather, the similar to the one that Lamar said, because of the hot weather. Okay, maybe. I need another hypothesis other than the hot weather. Thank you, Adnan, and thank you, Lamar. I need another hypothesis. I want new voices here. I want to hear
Ustad,
your
what
voices.
is the question?
Adam Hashashi, who's asking what is the question?
Me, Hassan Watson,
San Watfa.
because the answer
San, first you have, question is, why do the frog need 3 times more oxygen in summer than that in winter? Why do the frog needs oxygen 3 times more in summer than that in winter? Adam Hajaji, your answer is, why do the frogs need oxygen 3 times more in summer than that in winter?
Yes,
Yes, your answer.
because in summer
First. No because. I told Adnan about this. You don't use the word because. Hypothesis. This is the hypothesis. Why? Maybe.
maybe
Okay, we can choose other than Adam. Let's move to other than Adam. Thank you, Adam. Pay attention to this notes, please. Pay attention. I want to use Michael. What do you think, Michael Hussaini? Can you give me your hypothesis? Why do the frog have difference in the oxygen needs? Why do the frog need oxygen 3 times more in summer than that in winter? Yes, Michael. Michael. I think Michael has a problem. Ali Nasruddin, what do you think?
yes.
What do you think? Your hypothesis. Pay attention, Ali. Pay attention writing the notes. You told me the notes that are not important. I wrote some notes, right? Pay attention, Ali. Yalla. What is your hypothesis? Give me your hypothesis right now. What do you think? The frog needs more oxygen in summer than in winter. They told me because of the hot weather. Can you give me another hypothesis?
Is this gonna answer?
No, don't raise your hands before don't ask her before I ask you to do so, please. Okay, let's move to choose other than Ali. Karam, what do you think? Karam Atwi, what do you think? What is your hypothesis? Why do the frogs need oxygen 3 times more in summer than that in winter?
Ustaz, in
Other than the
summer,
hot weather.
because Ustaz,
Don't use the word
because
because. Don't
they
use the
move
word
more
because.
and they have more energy.
Okay, they need more energy. Very good. Since they maybe they need more energy, so that they need more oxygen. So don't use the word because. Very good. Thank you, Karam. So maybe they need more energy. Okay, excellent. So let's move here. We said that the pulmonary respiration, it ensures about 70% of the needs, meaning that it gives 70% of the respiration. So you have pulmonary and they have cutaneous. So let's move to the, according to the text, indicate the 2 types of respiration in the frog, as well as the used respiratory organ. I need Carlo. Good morning.
Good morning.
What are the 2 different types of respiration, Carlo, in the frog that are mentioned in the text? They said pick out from the text, so you have to pick them from the text. So what are these 2 types of respiration? You are mentioned in the text. Yes, the frog has a yes, Carlo.
Right, just wait 1 minute.
Oh, here's the text. You have to pick out from the text.
Ustaz?
Yeah, wait a minute, Jude. Let's see Carlo if he has an answer. Carlo, do you have an answer? Okay, I'm going to pick another student. Let's move now to Mia Hassan. What do you think? What are the 2 different types of respiration?
Pulmonary and
Pulmonary respiration, very good. It's through what? Through the lungs. And the second one?
is the cutaneous respiration.
Cutaneous, it's through what? Through the skin. Okay? So we have 2 different types of respiration. The first one is the pulmonary respiration, and the second one is the cutaneous. Pulmonary through the lungs, cutaneous through the skin. Thank you, Mia. Moving now to question part 2. Draw out the characteristic that favor the gas exchange between the plant and the surrounding. Well, the meaning of draw out, meaning that pick out, draw out, don't draw. Pick out the characteristic. Let's see who's raising his hand or her hand. I want a new voice here. Yes, Ahsan Watfa, can you answer this? What is this characteristic?
Yes,
Yes, it's mentioned in
the
the text.
characteristic allows the gas. Yes, gases exchange between the blood vessels and the surrounding.
Okay, what is this characteristic? The skin is composed of what? Of thin membrane that contain large network of blood vessels. This is the characteristic here.
Yes.
Okay? This allows the gas exchange. Since we have large network of blood vessels, we have high number of blood vessels. Thank you, Hassan. Moving to part 3. How does the type of respiration vary? It varies according to the season. Since in frog, it needs more oxygen, and the pulmonary, respiration ensures 70% of the need. Part 4, I need new hands. I'm going to pick now Nura Rasas. What are the two phases of respiration? We have phase that we do so, and the other phase. What do we call these phases? What are the two phases, Yanura, of the respiratory movement? I mentioned them while I'm explaining. What do we call these two phases? Yes, Nura? Okay, I think Nura has a problem. Let's move to Hala Safiyaddin. Hala, good morning.
Good morning.
What are the two phases of respiration? We have when we get in air, when we get rid of the air. What do we call them?
Inhalation and exhalation.
Excellent, very good. Inhalation and exhalation. And here they are mentioned. Inspiration and expiration. Inhalation and exhalation. Very good, Hala. Thank you. Part 5. Formulate a hypothesis to explain the difference in the needs of oxygen gas between summer and winter. Maybe due to the hot weather. Maybe the frog is active in summer. You, a human, we are active in summer. So we need more oxygen. We need to exercise, to play football, to run, to swim. So we need more oxygen. That's why we need more oxygen gas in summer than that in winter. So pulmonary and cutaneous respiration, there are the two types. If you have to mention the organs, pulmonary, it's throughout the lungs, and the cutaneous through the skin. So the characteristic is the membrane or the skin is composed of the membrane that contains a large number of blood vessels. Variation, the needs of frog is 3 times more in summer than that in winter, and also the pulmonary, it ensures 70% of the needs. Part 4, what are the two phases? They are inhalation and exhalation. Hypothesis, you have to write the word hypothesis, colon, and meaning that 2 points over each other. This is the colon, and maybe during summer it's more active, so it needs more oxygen, and this is for the hypothesis. So pay attention to these notes, pay attention and practice. The exercise 1 is very, very, very important for our quiz.